In this video, I'm going to look at a Viking Model 662E. This is a very old radio that was sold by the Eaton's Company, made by Electrohome in Canada, and it was manufactured in either 1936 or 1937, so this is a real rare beast, and we're going to overhaul it now. Check out what I'm going to be working on next here. This is a very old radio made for the Timothy Eaton Company of Canada. It's a universal radio product. You can see the model number there and the chassis. I'm going to have to look up service manual for this thing. This is an old tube set. It'll be AM and probably shortwave. We get a look at the front of the unit before I pull the chassis. I'm going to pull the chassis out so I can work on it on the bench out of the radio. Let's turn this thing around so you can take a look at the front of it. So there's the front of the radio. So say this one probably goes back to, I'm going to guess, probably maybe the 1930s. I don't know. I'm going to have to look up the chassis on this thing. But what we do know on this is it uses an electromagnet speaker. If we look back at that speaker on the back, notice the number of wires going out of the speaker plug down to the speaker. There's 5 wires. Now the connections as follows. One wire is a ground, safety ground, and you're going to have a B+ line that goes to the audio transformer, primary, and returns to the output tube. And there's also another B+ line that goes down through the electromagnet for the speaker, and then it actually returns back to the chassis to power up other tubes in the design, which we'll see when I get the schematic. Now, of course, the disadvantage to this design is that you cannot run the chassis without the speaker connected. The actual speaker is part of the actual circuit. So when I unplug this speaker to work on, or when I unplug the chassis to work on it, I actually have to remove the speaker from the cabinet in order to plug it in and do any tests, because you won't have any B+ on any of your tubes without the speaker connected. Before I even plug this thing in, I'm going to pull the chassis because this thing's probably going to have a bunch of paper caps that are going to have to be replaced, and I don't want to power this thing up until I've actually had a chance to inspect and make sure that there's nothing shorted. So we'll get the chassis out of this thing and then can work on it from there. So I'll start off by removing all the knobs. So these are held in place by just a set screw. Okay, there's the chassis on the bench. I haven't turned this thing over yet. I'm just taking a look at this. Here's the light for the dial. It's got the broadcast band, 55 to 170 kilocycles, and 6 through 18 megahertz shortwave. So it covers a good portion of the shortwave band in one band. Let's just take a look underneath this chassis on here and look at what greets us here. Wonderful. This thing is full. What the heck that's come from? A bunch of stuff is falling out of this thing too. But we are full of paper condensers on this, and in order to fix one of these things correctly, every one of these paper condensers has to go. There's not that many, but they all have to go. And the reason that these have to go is because what happens on these, I'm not even going to plug this thing in until I replace these condensers. And the reason for that is what happens on these paper condensers is the paper goes acidic. and they start to leak, and basically they turn into a resistor. And once that happens, someone's job here, someone just got a wire just hanging out there in free space. Once that happens, what will happen is it'll throw your bias off on your tubes, and you can cook your tubes. So something like this, these capacitors, these type here, these all have to go. You'll end up with a shorted or a leaky capacitor, and it'll overdrive something. It'll make resistors burn up. So I'm not even going to apply power to this unit until I've at a minimum changed out these capacitors. Now I'm going to be replacing these capacitors, these paper capacitors in here. I'm going to be replacing them with Mylar type caps, and these are not polarized capacitors, but they do have a shield, a foil shield. And basically what you do is you use your scope to determine the polarity of a capacitor. Here's probably a better indication. I'll slow the scan right down. Okay, now if I reverse the probes here, I can actually stop this while I reverse the probes here. So this is our reference, and then when I release it, we'll see that is higher, right? So there's one polarity. This is the shield here. This is the negative side because I'm picking up more RF, and if I reverse the connection and put the ground on the shield, if I release it, we'll see that the amplitude drops. That's how we determine the polarity of these capacitors. So that means this is the negative side here, because this is the low. I'm causing that because I'm touching the actual lead here by my hand. And the reason that you want to do this is because you want the outer wrap of the foil, which is connected to one lead here. You want that going to ground. You don't want to put that to the coupled input. That is going to be to the ground side of your device. Anyway, I'm going to go test all the rest of my capacitors here, and then we'll start changing out these 0.1s on this old radio that I've got here. Now, I couldn't get all of the capacitors that I need. I have the electrolytic, so that's not a problem. I've got the electrolytic, the main filter cap, and I've got a little bit larger electrolytic. This one's been changed before. This is a newer one. What I could not find any info on is this. This is a multi-stage capacitor, and I have no idea what it is. It's marked as a solar G-258, and I haven't been able to find any information on this capacitor. I also have not been able to find any service data on this radio. So I'm going to start by just changing the caps that I know definitely, without a shadow of a doubt, these ones got to be changed. These paper caps have by now all turned into resistors. Now if you look on some of these ones here, you see it says on this one here it's marked. If we zoom in the camera here, right, it says outside foil right here, outside foil. So that's what's going to go to this side. This is the outside foil, and again, how we determine that is using the scope. We just looked at the amount of interference that gets received, because the outside foil, when I'm hanging onto it with my finger, my body's going to act like a big antenna, and it's going to induce noise into that outside foil, but not to the inside. So when we put the ground on this terminal and we put the probe on that one, it's going to pick up that interference. But when I put the ground on this side and put the probe tip on this side, the interference is going to be much less. And that's just something to keep in mind when you're working with these non-polarized type caps, is that they aren't polarized as per speak, as in like an electrolytic capacitor where if you put them in backwards they're going to go boom, but they are still polarized in the sense that they do have a polarity. They have an outside foil, so we need to make sure that we get the outside foil. And see, they're all marked foil. This one's marked foil here, right? So we just have to make sure that the side that's got the foil on it, which in this case is this side over here, we have to make sure that that goes to ground. Okay, so now that we've covered that, I think it's time to start changing these 0.1 microfarad capacitors. I should have, how many did I say I needed? I think I had 4 of them in this thing. I hope so, because I think I only bought 4. But anyway, I should have enough here. Okay, let's start changing caps. So we'll start out by just removing this first one that I can see here. And I'm just gonna cut the leads off here close to the capacitor itself and try and fit these other ones in. Because obviously the new ones are a lot smaller than the original ones, but capacity-wise, they are the same. So I should be able to just bend the leads over here and place and solder the capacitor in here, and we'll just attach it to the existing lead that was there and take it from there. I have no idea whether this old vintage radio is going to work when I just change out the caps. We're starting out with capacitors, and I have no idea whether the tubes are any good on this unit or not. I'm keeping my fingers crossed. The only one that's in question right now is the rectifier tube, as the getter doesn't appear to be nice and dark like it should be. It's silver colored. It's almost hasn't gone milky white. It's just that there is no. I'm making sure this thing's discharged, by the way. There is no getter left. I'll show you here. But this one tube here, you see, this is the one that's in question as to whether this one here is actually still under vacuum. Normally, when the getter goes bad, or when the vacuum goes bad, the tube itself, the getter will turn like a milky white, which it's not. But I just don't see much of a getter in here. All these other ones here, no problem. You know that these ones are still under vacuum because they got the nice shiny, getter material here. So that I don't know. So this is an old capacitor here. This is an old Philco. This thing here could very well have PCBs in it. It doesn't say. Therefore, you have to assume that it does and dispose of it accordingly. Okay, that's the first one, and I'm just going to work my way through here and change all these 0.1s out. There's not a lot of capacitors in this thing that actually need to be changed, at least these paper caps. There's not a lot of them in here, so I'm going to change out all these paper capacitors with the exception of this bad boy here because I know nothing about this. I see one of the wires has come off here. That's a ground, so I'll have to reattach that. But then we'll hook this thing back up to the speakers and see whether it does anything. This radio's owned by a client that brought it in and just wanted it restored as as I guess reasonably as possible. And so we're going to try and get this thing going. And I told him at the start that we absolutely have to change all these paper condensers out because if we don't, we run the risk that we'll blow up a bunch of tubes and burn other stuff up if we put power to it. So I have not attempted to put power to this thing just yet. Pretty sure that that's where that goes. It looks like it just broke off that tab. Okay, next will be this next one here. And you can tell, I mean, if you look at the wax on this, the wax is all bulging out, so you know that made in Canada by Aerovox Canada, Hamilton. This is the outside foil, which goes to the back side here. It's another chassis ground. So this is going to be another probably cathode follower, this cap. So let's get the next one in place. And again, just like before, just going to tin the wires up here and solder it down to the original wires, because these ones are a little shorter than the originals. Okay, that one's on there. Same on the other side down here. I'm just gonna okay, it's two of them. Another 0.1 down here. That goes to this terminal, that one there, so that's an easier one probably to get at. Outside foil to shield. Okay, that's three of those ones done. I think there's one more here that I've got. One more 0.1. This one's a Philco, made in Canada again. This was obviously Canadian made radio. This is a old Eaton's Viking. It was made by the Electrohome company. But as of yet, I have no service data. I mean, I was on some of the old antique radio sites and I found tons and tons of data for Viking and tons of data for Electrohome. But wouldn't you know, this model, I had nothing for this one. Everywhere I looked, could not find any info on this radio. Which is too bad, because it would really be nice to have service data on something I'm working on, right? Twist those ones together and solder them down and then clip off the excess. And you know that today they would never be allowed to make something like this, right? With a bunch of bare wires with high voltage on them just hanging there in the chassis. You'd never get away with this today. Everything would all, you know, just for safety reasons, they would never be allowed to make something like this. I mean, they'd have to at least they got some insulation material on that one, but they'd have to at least insulate all the bare wires so that there's no possibility of them touching or anybody getting jolted or anything, right? But nope, this goes back. I say this radio is pretty old, and back then they just didn't have to do that. Okay, now I'm on to the 0.1s. I believe there's 3 of them that have to be changed. Or 0.01, sorry, 0.01, 0.01, and 0.01. And what is this one up here? And that's a 0.003. And that should, so there should be 3 0.01s and a 0.03. And that should do the capacitors on this thing. At least it'll do all the paper caps. And like the last ones, the shield is on the side here on the right side. That's the shielded side on this one, so that goes to the negative side, which is the side that will say shield. Cut that one out. And on this one here, there's the outside shield there, so the outside shield on that goes obviously to this terminal here. This is going to be probably, looks like this is the input to one of the amplifiers. I think this is the volume control. Yeah, that'll be a volume control there. So and the other one I can probably even put it right into the control here. Should have enough. I should have enough lead here to do that. I can even put it back into the asbestos containing. I'm sure that there's asbestos on this. I'm sure all this wiring, all these jackets on here, they're going to have asbestos in them for sure. Because back then, asbestos was considered to be a very useful material. Same with PCBs. They were considered to be useful materials too until we found out they caused cancer. So I want to be careful not to disturb any of these tubes here. I don't want to cut them or anything, because asbestos is not a problem unless you disturb it and create fibers. So I don't want to cut anything or break anything. Okay, that one's done, and there's another one down here. Oh, wonderful! Look at that. That's beautiful how that's just sitting there in free space. Another 0.01 down here. We'll just change this one next. That was broken right off. That one, this lead was already broken. So outside foil is on this side. Okay, that's the second one done. The third one is up here. A little harder to get at. Me, so I'm going to lower the camera down a bit more so you guys can see it. Maybe not. It's hard to see, but it's right here. And this one's a Sprague. This is an American-made one. Outside foil again, marked on here. So well, it looks like I was able to find the service data on this radio. It's a Series 662E. Look at the date, 1936 and 37. That makes this radio 80 years old. So this will be really interesting if this thing actually will work. Anyway, just looking at the layout here, it's not a push-pull output like I first thought. It's a single-ended output. The number 42 tube here, here's the output. It's a Pentrode design, but it's a single-ended. So here's our tube layout, and here we have a 6A8, which is going to be the oscillator, and it looks like mixer, and 6K7 is going to be IF stage. And we get a 76 and a 6F5. Those are going to be detector and detector and the preamp. And the 42 is the audio output. And the 80, this is our full wave dual diode rectifier tube. And here's our speaker transformer and our speaker, which is again, it's a electromagnet speaker. So there's high voltage that goes through that plug down to the speaker and the output transformer. Anyway, back to replacing the last of these capacitors. I couldn't get a regular standard poly type cap, so I ended up getting one of these orange dipped caps, which are actually a little better quality, but a lot more expensive. So let's just replace this last one. This is the .33. I think it's .033 or .003 is the size, and that one goes right up here. That's great for the speaker plug. Oh, it's this one right here, .003. So that's on the cathode to plate. Anyway, we're gonna change that one out, and then I'm gonna just try. I'm gonna try this before I change any of the electrolytics on it, because they may not be in as bad a shape. We'll bring it up slowly on the Variac and see whether we get anything whatsoever. I'm just checking this cap for the polarity, and once again, the right side of this cap here is the foil side. That's going to go in like this. Okay, that's the last of the paper caps that I've gotten out of this thing. The next thing I'll do is I'll plug the speaker into it and we'll bring it up on the Variac very, very slowly and see whether we get any B+ and see if we get any noise whatsoever out of this thing. So of course here's the speaker for this unit. As you'll see, I'll show you the back side of it. Okay, this is an electromagnet on the speaker. So underneath this cover, if I were to remove this cover, which should just unscrew, this is for those of you that have never seen this type of a speaker before. This is actually an electromagnet. So there's, not only does it have a voice coil on the cone itself, but it also has this big coil around the back. And when your B+ is applied through this coil, this produces the magnetic field that has, of course, been replaced on more modern speakers by a permanent magnet. So you've got two coils. You've got a coil to produce the magnetic field, and you've got the audio signal which goes to the voice coil, which is around the middle there. So that's called an electromagnetic speaker. And they put this shield around here. And of course they did it this way back in the early days because they hadn't developed good quality permanent magnets back then. So that's why they did this. So we're going to plug the speaker plug in here. It only goes in one way. And now I'm going to apply power to this and bring the voltage up. I've got it going through my current limiter as well, so we shouldn't have any surprises. We'll just bring the voltage up slowly here and see whether we get any noise. Okay, we're up to 130 volts now, so that means that the rectifier is starting to work. I'm only giving this thing about 50 volts right now. So, and there's nothing showing on my light bulb. We're not drawing any significant current. 284 volts there. 76. So we got power. It's my B plus. Look, where is my B plus? Where is my B plus? 290 volts. 253. Okay, I got B plus. Now I'm going to bring the service diagram out and take a look for some voltages here. Okay, our volume control is here, and this injects into the 6F5. So I'm going to put my scope up here and see whether there's any noise coming in from the detector. Oh, what happened there? I'm just looking to see if I see any audio appearing on the scope. I see noise as I tune the band up and down. I don't know what band I'm on. Let's try the other band. And I'll let you guys see for yourself whether you think that looks like audio. Sure looks like audio to me. Okay, so I think we have an amplifier problem here. If I tune the tuning, watch what happens here. Okay, so what does that tell us? That tells us that the front end is working. The RF section is working. We're actually tuning in the station, and we have the signal present right here coming off of the detector. This is our volume control, and that's going to feed into the 6F5, which drives the 42. Guaranteed both of those tubes are probably, good luck trying to find one, but that's the output from the detector. Let's go to the input. This is the volume control here. You should see now I turn it up and down. So now we've got the signal here. This is actually should be on the grid to the 6F5. I'm going to just trace the wires here to make sure that there's nothing broken, but I'm now connected. If we look on the schematic here, my probe is right here. Now, so this should be presenting audio to the 6F5. I should be able to get audio on this 0.01. Probably one of the ones I just changed that should be off of the plate. So that's the next place we'll look to see whether I'm getting an audio signal through the 6F5. And it should be on the 0.01 connected to the plate. That'll tell me what pin that is, so it makes it a little tough to find, but I think it should be this one over here. Turn down the volume. It goes down. That should be the plate. That should be right here. Where was it? That should be right here. So that would then provide the signal to the grid of the audio output, which is number 42, and that should go in to one of the grids there on that tube. Let me just see if I can trace this by eye here. This one here. That should be my audio input. That's my grid input. Okay, so that's my input there. You can see it on the scope. That's right here. That's on the grid input for the output tube. We're making progress. Meter's going to turn off now because it's telling me that it's been timing out so it beeps before it shuts off. I was trying to give you guys a little better view of what I'm doing here. So we should have audio going to the speaker. If that tube is working, it might be this tube is bad. It might be that tube. But we have grid. We have our audio signal at the grid for the output tube. So we should have audio on the speaker, and I'm just looking to see which pin it should be on here. Yeah, that has a very low signal on it. Very low. I can see audio, and I can see it when I turn it down. This is the input to the transformer. It's like, is there... See, there's our input. That's our grid. See how strong that is? Yet the plate output is really low. Heater, and that's heater, and that should be ground, and that's grid. So that's cathode, grid, plate. I think this is suppressor grid here. Is this one? Okay, I'm making some progress here. I think I'm missing my plate voltage. This should be my plate here for the output tube, and it goes, power goes in to the speaker, and one goes through the voice coil, or one goes to the transformer and one goes to the voice coil, and it returns back as B plus, and the other one should go to the plate. I'm not getting any voltage back. I wonder if there's a problem down here at the transformer. Should be a red and white wire. Just going to check continuity on the speaker plug here and see why I'm not getting continuity back. Okay, that one's ground, so I'm just going to put the meter here in ohms mode. I should be able to ground this one here and measure ground to the speaker frame. I think this is ground. Yeah, that's ground. Okay, so we should have continuity between a couple of these pins. One is the coil for the speaker, 1.9 kilo ohms, and this one should be the transformer, I'm thinking. And it's open. I see. That might be our problem, Houston. We may have an open transformer for the speaker output. This is our speaker down here. Now, if that's the case, I should be able to just bridge another transformer in there and test it from another radio, if I can find one. I guess the only way to tell is we're going to have to cut these wires at the speaker here and just test the transformer. It's easy enough to put them back together. Looks like it's open. Looks like the transformer is open. I hate it when that happens. Because you know that finding one of these transformers is going to be next to impossible. Yeah, the transformer. See, there's my winding. I guess you guys can't see on camera, but Here's my, I'm just measuring my transformer winding here, and it's open. Going to the mega ohm range, right? It's open completely. That is why we have no sound off this thing. So let's just see whether I can find a transformer to substitute. Now, for those curious as to what would have caused that audio output transformer to fail, that would have been the 0.003 microfarad cap, the little paper cap that was across between the speaker terminal and ground. That basically is connected between the plate and the cathode of the output tube. And when those paper caps go leaky or short, that would have pulled full B+ current through the transformer to ground and caused the primary winding to fail. So what I'm going to do is I'm going to use as an ordinary audio or an ordinary AC transformer. This is an AC input, AC output. And we're going to use this just to see if I can get some sound. It won't be correct, but at least if I hear some sound coming out through the speaker, then at least I know that that's our problem and that everything else should work. So I'm just waiting for the tubes to warm up, and then we'll turn the volume up here. I got sound. Okay, I got the wrong transformer on there, but I got sound. I'm just using a AC adapter. I'm just using an AC adapter here. 110 volts in, 15 volts or 18 volts AC out, so it's not the right impedance at all. But listen, I had sound. It's an 80-year-old radio. So what I need to do is I need to find a transformer for this thing. I can't proceed any further until I find a transformer that will work. But I've made progress. I have sound, which is more than I had when I started. That tells me that the tubes are all good, and that tells me that the caps that I replaced are working, and my electrolytics, this is an electrolytic here. I didn't change it because someone else has already done that. I don't know how old it is, but it's certainly not 80 years old like the other ones were. And it's not the type that would normally, it's not a paper cap, right, that's going to go bad. I couldn't change that because obsolete. I don't even know what's in it. It's probably one of the ones that's listed on here, multiple caps in one box. But as you can hear, let's see what the tone control does. Can't get much volume out of it. I don't have it on much in the way of speakers. Got lots of sound on the scope. The reason we're still low is because this is the wrong type of transformer. Anyway, I gotta find a transformer for this. So I'm gonna close this video off now as we've diagnosed the problem. A bad output transformer on the speaker. We've diagnosed the problem, we've replaced the capacitors on this thing, and now I need to try and find a transformer, and that may be a challenge. So if I turn it down, the sound is very low, but it's actually quite clear. If I put another transformer on there that has a little bit higher output voltage, we'd probably hear a little more from these speakers. But anyway, hey, we know it works to this point, so I hope you enjoyed this troubleshooting video on this 80-year-old vintage 1936-1937 chassis. It's an old Viking made by Electrohome. That's how you service these old beasts. And I'll make a part 2 video once I'm able to track down a transformer. Now I gotta go do emails and see. I gotta find out what the transformer is worth and give the owner of this an idea what he's looking at to do the job. This isn't my radio, belongs to a client, but at least now I can give him a call and let him know what I found and what we're up against, and hopefully I can find a transformer for it. I mean, even if that coil on the speaker, I'm sure that the magnet on here is okay, because if it wasn't, the radio wouldn't be working, because it's going through there first and then coming back to the chassis. Now comes the hard part. Trying to find a transformer. Had main electronics not shut down, I think that would have been a relatively easy task, because they had all kinds of old obscure things, but now I have to really do some work. Hope you enjoyed this look at this 80-year-old radio, and we'll pick this up when I find a transformer and complete the job.